So again, let's look at the numerator here. The numerator is just 1. There's nothing else I can do with it. There's nothing more stronger or weaker. There's only one term, so that's fine. Clearly, n squared is going to be much bigger than 1. So I'm going to rewrite this as 1 over the square root of n squared, n equals 1 to infinity. And hopefully we're all okay with the square root of n squared is equal to n. So this is the same as n equals 1 to infinity, 1 over n. Oh, what is this? This is the classic harmonic series. That diverges p is equal to 1, right? Which is less than or equal to 1. So let's use this series in comparison with this one and use my limit, provided I don't get 0 or infinity. I've chosen wisely. So the limit as n goes to infinity of 1 over n squared plus 1. Note, it doesn't matter which one I put in the numerator. The series that I know or the series that I'm working with, it doesn't matter. You get the same result. So this turns into the limit as n approaches infinity of the square root of n squared plus 1 over 1 over n. I did that wrong, sorry. N. So I multiply top and bottom by 1 over n. And notice that when I slide this back in, I square that term. Why is that? Well, the square root of 25 is equal to 5. So if I put this back into the radical, how would I do that? Well, 5 is the same as the square root of 5 squared, which is square root of 25. So notice if I want to put something back in, I square it and add a radical, and I get the same result, right? So therefore, I'm going to put this back in. This can be 1 over n squared. So this is the limit as n approaches infinity of n squared over n squared plus 1 over n squared square root 1. This is the infinity, 1 plus 1 over n squared over 1, which is equal to 1, right? So this is not 0. So therefore, I've chosen wisely, meaning that these two series behave the same. So this guy diverges because it's a harmonic p series. Diverges, so therefore this one diverges as well. So I'm just going to add diverges by limit comparison, and I'm all set.